what do we call graphics. Okay. So in statistics, how many of you had already finished your statistics? You had biostatistics or something
Yes,
like
ma'am.
statistics.
Yes, ma'am.
Yes.
Yes, ma'am.
Okay. So only Nihal and his friends or someone else also. I don't know how many school college people are here. VIT, apart from VIT, who else are here? Amrita. You can answer at least this question. Yeah, there's not going to be any punishment. Yes, Arpan. Where are you from?
Ma'am, Amrita, Amrita.
Amrita. Amrita VIT. VIT में भी है?
Yes, ma'am.
Okay. So what we'll do is, so what do you mean by statistics, by the way? Since you already had a bit of statistics, what do you mean by statistics, first of all? Can anyone tell me?
Ma'am, analysis and interpretation of data sets.
Exactly. So analyzing any data you have, you just analyze it, summarize it. Okay. So that is exactly what statistics is. So everybody remember, statistics is based on the type of variable. Okay. First of all, whatever kind of data you have, you'll have to see what is the kind of data you have. Kind of data here means, is it numerical or is it a character, or qualitative character, quantitative character? Depending on that only, you will decide which kind of statistical test you have to apply. For example, how many of you know that quantitative means something you can measure? So can someone give me examples of measurable variables?
Ma'am, height, weight,
Yes.
age.
How do you quantify height or weight? How do you measure height or weight?
Ma'am, units of measurement, kilogram, meter.
True. Okay. So for this, you can such measurable numbers can be analyzed with the means of mean, standard deviation, mode, etc. Okay. Okay. Suppose if I am asking you all your phone numbers, okay, that is also a number, right? So do you think I can do mean, mode, standard deviation, etc. on those numbers? So when we said quantitative, we said something to do with numbers and again measurable. So there are two difference here. Just because you have a number doesn't mean that you can do all the kinds of statistical analysis which can be done on numerical data. Okay, so depends on which numbers. Say suppose you have ranks, right? First rank, second rank, third rank. But do you think you have 1.5 rank, 1/3/4 rank, 10.5 rank? Do you have something like that?
No, ma'am.
So these are all whole numbers. You have one children, two children. You don't have 2.5 children, 3.5 children. You can't make mean and standard deviation out of this. Okay. So you have some among numericals also two types. Whole numbers, one which belong to whole numbers, the other ones which can even take integers, decimals part. So most of the time, mean, standard deviation, variance, etc., can be only be done on such variables. Okay, not for whole numbers, not for ranks. For these things, you have other set of statistical tests. So what would you do with say suppose ranks are there, say suppose whole numbers are there. How many children? 2 or 3, 5, 6, 0. For these, what you can do is you can start doing frequency distributions. Everybody must have done frequency distributions. For example, you can calculate average or mean by simply totaling all the values by total number of variables you have. Whereas another way of doing it is in frequency distribution table, where you keep measuring, put them into class intervals and then finally do it. I hope, everybody must have done this manually, right?
Yes, ma'am.
Yeah. So now,
Yes, ma'am.
yeah.
Yes, ma'am.
So now what we'll do is see how basic kind of statistics can be done in R. Okay. Now always remember, in R you have different data packages, right? For each package you have your own set of sample files in it. Okay. So what you can do is you can use that for a start to do different kind of statistical analysis. Okay. For example, I'll start sharing just a second. Able to see the screen?
Yes, ma'am.
Yes,
Yeah.
ma'am.
Yes, ma'am.
Now
Yes, ma'am.
column for a data set called MT cars. See, it's an already inbuilt data set provided in R. So you can just click on that, you will get to see this. Or you can see view MT cars. Okay, here on the upper hand ones, you will get to see this data like this. See what are the different columns you have? It is something to do with cars and their internal what do you say parts, which are very important to uh, which is very important while buying the car. Okay, so depending on the model you have mpgs, cyl, display, hp, drat, wt, qsec, vs, am, gear, carb. Everybody able to see this data set?
Yes, ma'am.
Yes. Okay.
Yes, ma'am.
Yeah. So what happens every time, you don't have to see all the variables in this. If this being a very small data set, what happens is you're able to see all the variables in here. So instead, what you can do, you can give something called head and give the same name, empty cars. I'm so sorry. Empty cars. See what happens. First 5 rows of data will be visualized instead of the whole data set. Okay, so you can always use view or head, okay, to see how your data is present. Okay, now suppose you want to further know about what each mpg or everything you need to know about this data set, you can give a question mark followed by mt cars. Okay, so what happens here in the help window where you can see packages and all, it will give you a description of what are the variable, all the variables names. mpg means miles per gallon, cyl means number of cylinder, etc. So all those information you will get to see. Okay, now suppose I want to see what are the different names or of the columns, etc. Before I do any kind of statistical test, you can also have something called dim, means dimensions of the data set. Dim, empty cars, and enter. What did it give you? What is the answer you get? you have 32 and 11. That means in a column of total 11 number of columns, you have 32 entries. Okay, total number of rows and total number of columns. DIM will tell you total number of rows and total number of columns. Make note of these because this will be always useful. Say suppose you are using your own data. Before you proceed or to do any kind of test, it's good to have a habit of looking into how your data set looks like. As I told you in earlier classes also, it's very important to know about your own data, and each type of statistical test or a graph, if you want to plot, has a different way of, you have to rearrange your data into that particular format. So when you keep doing that, if there are any errors, you can get to see this initially in using these head, view, dimensions, etc. Okay, and you can also see the names in the given data set. See, it will give you the all the column names will be displayed when you use the function names. Say suppose you would like to know, these are the column names, right? Say suppose you would like to know the row names. So all you have to do is row names followed by empty cars. You get to see all those 31 variables. Apart from the first title heading, you will get to see all the row names here. Everybody got it till here?
Yes, ma'am.
Okay.
Yes, ma'am.
Say suppose you'd like to, print only, column specific data, you can also do that. Okay. For example, you just want to have look into complete only one column instead of all these columns. You'd like to see only one set of columns. Say for example, I'd like to see what is the number of cylinders, second column data. What I can do is you say empty empty cars followed by dollar symbol and see, you will get to see see all the columns here. So you click on CYL and just enter. You get to see all the values, all the 32 values in that particular column. Now we'll start with the simple first, statistics called summary. Okay, so summary function will gives the list of 6 statistical tests. That is minimum, maximum, first quartile, median, mean, and third quartile. So how do you do it? Give summary of empty cars and give enter. So what it will do is, it will give out the minimum, first quartile, medium, mean, third quartile, maximum of every column of data. Provided it's all quantitative. Remember this. Everybody do this and show me. I mean, just tell me whether you got it or not.
Yes, ma'am. Got it, ma'am.
Yes, ma'am. We got it.
Got it, ma'am.
Okay. Say suppose you don't want all this information. You just only want maximum or minimum. Okay. So what you can do, instead of summary, you just give max of what? Of empty cars. And if you give a dollar symbol, you can choose which column you want to have the maximum value. Just click on any one of your interest and it will show you the maximum value of that particular column. You can do even minimum also. Do the minimum and tell me of the same HP. What is the minimum of that?
I'm 52.
52, ma'am.
52. 52.
52, ma'am.
Very good. Just a second. Okay. Now, say, suppose we'll do it the other way. Say it's called which max and which minimum. Okay. Now, say, suppose I give the function which dot max, okay, of my data empty cars followed by same horsepower. I want to see which of my which of the cars has the maximum horsepower. Okay, and it gives out 31. Okay, and again similarly, I can say which of minimum empty cars of HP, okay, which is 19. Now 31 and 19 doesn't make much sense, right? I want to know the names of those cars. Okay, getting a data value is okay, but it would be even more better if I get the names. 31 belongs to which car? Okay, there are 31 cars, right? So we'd like to see which one has the maximum and which one has the minimum. Now I can add row names to the above one only. Row names, empty cars, okay, followed by, now here you open the square brackets, which max, similar ones, what we had done earlier, which max of my empty cars HP. Now you get to see the name of the car also. So Maserati has the maximum horsepower. Similarly, I can do which minimum and see which car has the minimum horsepower. It is Honda Civic. Got this?
Yes, ma'am.
So yeah, so this max and minimum can further be used in a data set when you are measuring something and you'd like to see outliers. That means too high of a value or too low of a value, which is out of range, say suppose. So such things can be used for this. Okay, now suppose why don't you just tell me which car has the maximum, mpg, based on the mpg, which car is giving you miles per gallon highest and lowest? Can any do it and just tell me which is the car just having that maximum minimum based on the column name mpg, that is miles per gallon for 1 milliliter of petrol, which is giving the maximum speed, distance. Calculate and tell me.
For maximum, it's Toyota, and for minimum, it's Cadillac. Fleet.
Very good. Good. That is very fast. Okay. Now we'll go with mean. Okay. So just as earlier ones, you don't want to have a mean of all the columns. You want to do it with certain only one column, say. So now here you use the function called mean and empty cars with weight, or I'm using it the column WT, and see I'm getting my mean value. So you can do this to any column. Can anyone do it for the first column and the second column?
Ma'am, for MPG, it's 20.09062.
Okay.
And for CYL, it's 6.1875.
Superb. Very good, Aditya. Everybody got this till here?
Yes.
Yes, ma'am.
Cool. Now we'll see mode also. What do you mean by mode, by the way? Try remembering your definitions or Google it. What is mode?
It's the one that occurs the most in the entire data set.
Yes, the same value, similar kind. Say suppose your weight is 50. How many of your others who have 50? So say suppose there are 5 people, and that's the similar kind of weights you see, and you see that 50 has most number of times. Then I call that as a mode. Okay. So I'd like to say check the mode. Just a second. The thing is, but R does not have a mode, specific function for mode. You only get it in summary. Oh, you do have it. Just a second. Let me check, because earlier we had problem. Wait. Okay, see, the mode means it will take it as, it will give the function mode here does not reflect the statistics, but the kind of data it has. Okay, so now still, how would you like to see which variable? Say suppose the same variable weight has, what is a mode? So what I do is I subset my actual data here. Okay, what do you mean by subsetting? You're not changing any of the variables, but making another data set out of this main data set so that you can do any of the functions. Okay, so here, say suppose I'm giving a name called data underscore cars, and I'm subsetting it from my main data set, which is empty cars. Okay, so now what I'm doing is I'm sorting names. I'm sorting it. Okay, sort, you say table of, now I've created this data, right? Data underscore cars with weight. Okay, 1, 2, 3. So what is it doing? It is sorting first of all. Okay, now I want to sort the first one. See, what it does is sorting means it will just give you all the number of values here, not all the values, just the frequent numbers. Okay, so suppose 3.444 is more occurring 3 times, so it will not show it 3 times here, unlike in the data frame. Okay, so here what it does is it will give you list out all the values from that particular column, and then when I say it as 1, it will give you the number 3.44, which is the mode. Okay, can anyone do the similar ones for, say, HP mode? What is the mode for HP?
Now 110.
Everybody got the same one?
Yes, ma'am.
Yes, ma'am.
Good. So got this? So mode, unlike mean, you don't have a function called mode to calculate the mode. You have to sort it and then figure it out. Got it?
Yes, ma'am.
Then we'll see into quartile. Okay, quartile or quantile. So quantile can be quartile or 3/4. It can give you the 25th percent of the data or 75th percentile of the data. Okay, so here you can use, for this you have quantile. Okay, quantile function. So click on quantile and say Now anyway, I've subsetted it. I'm using that one, data underscore cars, or say suppose MPG, and I'm saying which quartile do you want. So I have to specify that 0.25. That would be 25th percentile. So you can give any percentile value and it will give out the answer. Okay. So it is telling me 25th percentile value is 15.425. So can anyone calculate it for 0.75, 75th percentile?
Ma'am, 22.8.
Right. Right. Okay. So you can do 0th percentile, 25 percentile, 50, 75, 100. You can even do 95th percentile. Any percentile, all you have to give the value in the brackets. Okay. Say suppose I want to make a 90th percentile. So it will give me the value in there. Okay. But usually it is the first, that is 0, 100, and then 25, 75 percentile and mean. Okay, all these are important. Why? Because these values will also be used to make a box plot also. Okay. Now let's come to bit of graphics here. Say, suppose I'm not taking any data set for now. We'll just say plot. Okay. Say, I say plot values of say 3, 7 and click on it. See what does the graph here shows into your right hand side. It will simply make a graph which you used to make. It will create an axis on both the sides and say 3 and 7. It will show it here. Okay, this is the basic kind of plot you can do. Say suppose I want to give 2 points in here. So I'll say plot, and I'm saying combine two values. 1,8. So by default, what it does is it will take the first value of x-axis and the second value as it on the y-axis. Okay, next, combine 3 and 10. Sorry, there's an error. Oh yeah. C18. Okay, spacing is very important. Be careful. Plot. Okay, comma also important. Yeah, got it. If you zoom it, you can get to see this like this, your plot. You have options here, zoom and export. If you click on export, you have copy, save as PDF, save as image, and copy to clipboard. So if you copy to clipboard, it is waiting there, and you can say, suppose you want to open a PPT and you want to paste it, you can do that. Okay. Please be mindful of the commas and space. So using this plot function, you can do simple plots as you do it in your experiments. Okay, you can do it on your without any base reference. Just you can do this. Okay, and I can even say I want x values to be. So combine 1, 2, 3, 4, 5. I want y variables to be combine 3, 2, 7, 8, 9, 12. Oh, sorry. Space, comma. And then say I can say plot x, comma, y. So you can see this like this. So if any one of you had done DNA, concentration wala test, you first take standards, and then out of the standards, you have to create a graph. Then you insert your, new value, and see, you have to predict from the y axis. You can do that with this particular graph also. Now you can ask me, ma'am, there are no, axis names. Okay. So what you can do is, there is something called, say for the same y, x comma y, I'm adding now a comma and say main, main. Main means it will give you the title. So title always should be, since it's in a character, you say it's my graph or graph 1 or something, anything. You can write the title in here, graph. Okay. Then you have X lab, XLAB. Okay. So that would be name of the X axis. So I'll just give it as X axis. Then comma, Y lab. Now again, Y axis. You can give any name, X, Y, Z. See, now your graph has a title, an X axis and Y axis. So you can keep on adding other functions also. Say suppose you want to color these pointers with red. You want to fill it. You will have every name, size. You can change the size. Okay. You can change the shape. So for the same axis, same above, functions, you just add comma. So I can say COL means color. Okay. So color is equal to, you have to specify. So I'll say it as green. Okay. See, your graph will become colored. Say I want to fill it with, I want to increase the size of the shape, pointers. So I can say is, you have CEX for the size. So CEX, instead of, I can say 3. See, your size of the pointers have increased. Say I want to change the shape. Okay. So you have something called PCH. PCH equals to, say suppose I'm giving it as 25. See what happened? Your pointers have become triangle, inverted triangles. You can just explore. Say suppose I want, my PCH I change to 19. Okay. What will happen? See, instead of the, now you'll have filled in pointers here. Okay. So on and so forth. You can just explore. Got this? Everybody till here?
Yes, ma'am.
Any doubts? Any doubts?
Ma'am, what basically is this PCH?
PCH, full form you mean to say?
Yes, ma'am.
Yeah, it is called as plot character. P for plot. CH means character. Plot
Okay.
character. Okay. The symbols you use, right? The point shapes. All these are called as plot character.
Okay, ma'am.
Okay. And CEX means the symbol size. That's it. There's no name for that, but that's the kind of argument used in R. Next, say that was plot, right? Now we can do a line plot. Okay, line means you want to create a line. Say suppose I'll say plot. Okay, plot 1:10. I'm giving a range here. Okay, and you say you have to say type, which type of plot you want. Okay, so here I'll have to give it in inverted or commas. L means line. Okay, and line width, how much I want, I give it out a number. See, you'll get a plot like this. Now say suppose I wanted a dotted line. Okay, so what I do is there's another parameter called, for the same one, add LTY equals to 3. See what happens? It's become a dotted line instead of a straight single line. So you can have long dots, short dots. You keep changing those numbers from 0 to 6, you'll get to see the difference. The LTY numbers, everybody try changing the same, using the same command, what you have used there, but just change the number for LTY to 0 to 6. You'll see different kinds of lines. Can anyone confirm after you do it?
Yes, ma'am. The dot pattern changes.
Yeah, dot pattern changes. And you can even plot 2 lines in here. Okay. For example, what I can do is, we have already used X and Y, right? So I can say plot X, comma, type. You have to give the type. Type as L, comma, I can give different colors here. COL equals to blue, UE, blue. Then lines. You have line and lines. Be careful, use the second one as lines. Okay. Then you have Y. Again, type. Again, L. Now we use different color. Red. Oh, some spacing mistake. Let me check. In plot. Type is L. Unexpected symbol. Where did I go wrong? Let me check.
Ma'am, type there is no space after equal to. Is that a problem?
Yeah, maybe. Yeah. Did you get it? No, let me rewrite that. Plot. Okay, plot. Line. X. X, comma, type L. Lines Y type. Got it. So I will just change here. Give a shift enter for before you start typing lines. That was a mistake there. Color. Here also color. Red. Okay, got it. When you type lines, okay, now you'll get it. Check whether you got it or not, everybody.
Yes, ma'am, got it.
Yeah.
Yes.
This was simple plot. Then you can have scatter plot. What do you mean by scatter plot? Say suppose I am plotting empty cars. Okay. In that one of we are trying to do two. We'll use two columns here. Okay. First one say MPG. Okay. Versus empty car. I'm sorry. I have to use the data set here. Yes. Versus say cycles, cylinders, number of cylinders. Okay. So see the graph you'll get. So here MPG is miles per gallon versus your number of cylinders. So you'll see the each plot, all those rows versus columns, each one will try to pick the other one. Okay, XY graph. Okay, so you can change instead of the same CYL, I can even give horsepower. Instead of CYL, I'll give horsepower. See now the scatter plot changes. Okay. So scatter plot, roughly gives us an idea. If you see, as the miles per gallon is increasing, the horsepower is decreasing here. It's kind of linear, inverse relation is there. Okay. So say suppose you have a data, you don't know, you want to find patterns, like is it following a inverse relationship or a linear relationship? Scatter plot will give you a rough idea. Got this?
Ma'am, what is the type L we are giving here, ma'am?
L was earlier, I want to say it has to be a line graph. Okay.
Okay.
Plots can be different types, right? It can be line, and or it can be just like I showed here, right? Scatter plot. Here it is point wise. Instead, if I would say here, here also you can say line. I want to use lines for MPG and HP also. You'll get a very haphazard kind of line. You will get it, but you'll definitely get it. Different kinds of graphs will be important. Say for example, you are making a bar graph and you still want a line on it. You can still type both here. Okay. So all you have to do is you should know what you want to get and then check for it. You'll get all kind of graphs. Okay. Say for example, I want to get a pie chart. Okay. Say instead of plot here, I say pie. Okay. Pie of what? I want same empty cars. Okay. Say for horsepower or cylinders, number of cylinders. See what are the kind of pie chart am I getting? Okay. So you can make all the kinds of graphs here. These are very basics, but what happens is there are some advanced versions of packages also for making 3D kind of charts, different colors, different cut charts, etc. But it's you can do there are just for graphs in R. You can have so many packages. You can make fancy graphs. Okay, these are all just basics. Okay. Now, say suppose you want to make a bar plot. What do you mean by bar plot? Anybody seen bar graphs? Hello, there.
Yes, ma'am. Background, yes, ma'am.
Yeah. So suppose you want to make a bar graphs here. Say I'll give a value called A. I'll create a data here. Combine. Say I'm just giving a numerical value. Characters. A, B, C, and D. And I'm so sorry. Then I have something called B. B. You are combining it with numbers. Okay. 2, 4, 6, 8. Now I'll say bar plot. Okay. Of what? Of Y. Sorry. Of B. And names dot arg. Okay. This is the argument used to put our names in the x-axis. Click on it, you will get a bar graph like this. Got this?
Yes, ma'am.
You can change the color, use the same argument and add colors. You can change the density. Density means, say suppose, so for the same argument, I'm adding density. Okay, density as 10. See how the graph changes here. Okay, instead of the fill in, you have lines in here. You change those numbers, you can have different kinds of densities in there. And I can even change the width also. Okay, width, I can change it to horizontal. Say suppose I want the same graph in horizontal. So what I give is HORIZ equals to true. You're saying yes, I want, I'm so sorry, true. And see, you have a horizontal bar graph. It looks even more better than the vertical ones. So it depends on the kind of graph, information you have. You can just play around with any kinds of graphs. Everybody clear till here?
Yes, ma'am.
Okay, so you have already some inbuilt package data sets in here. So you can just play around, download, open that, and play around creating graphs or basic statistics. Okay. Just a second. See, click on help package is equal to data sets. It will give you all the list of, data sets. You can find it in here. Click on help package is equal to data sets. You have inbuilt data sets which are present in R. Hair eye color. See, click on hair eye color. It will give you the names and levels of hair and eye colors in it. So I can say hair eye color. See, you can see some data here. Try creating, graphs out of this and put it in the group, okay? And similarly, I'll keep giving you some exercises in here to either do statistics or to do some kind of graphs. Okay, so see you in the next class. We'll discuss more on statistics, or you have anything specifically you want to learn or something like that, just put a message in the group. Got this?